Welcome back to Inequalities Part 2. We are going to move on to C of exercise 1, but I also wanted to point out that this x squared plus x minus 2 times x minus 3 less than or equals 0, the space here, go ahead and give it a try. See if you can figure out how to do this covering up the previous notes. See which method you like the best. Let's do x squared greater than x plus 2. First step is to bring everything to one side of the inequality. I'm going to bring the x over and the 2 over, and that will give me x squared minus x minus 2 is greater than 0. At this point, I'll go ahead and factor it. That gives me an x minus 2, x plus 1, greater than 0. Now I'm going to sketch my number line where if I set the binomials equal to 0, I will get x equals 2 and x equals negative 1. Putting these points on the number line, I'll have negative 1 first, and then we'll call this 2 here. Notice that since the inequality is just greater than, it doesn't have the equals to, I'm going to put open dots at these points. So an open dot at negative 1 and an open dot at 2. I can use the rules I know about this polynomial. This polynomial is a quadratic. That means it has a parabola shape, and if I sketch that general shape, it will cross through at negative 2 and cross through at, it'll cross through at negative 1 and cross at 2, and it will be an opening upwards parabola. This shows me that to the left of negative 1, my shape or my values will be positive. All the way up to negative 1. From negative 1 to 2, my parabola is below the x-axis, so those will be negative values. And to the right of 2, my parabola is above the x-axis, so we would say that the polynomial is greater than 0. If I write this in interval notation, I want to know where my parabola is greater than 0, so it's the positive regions. I can write that with a interval notation that will be from negative infinity to negative 1. Since this is an open dot, I will use a closed parenthesis. I have a region that is negative, and so I have to throw that out. So I'll just group it by saying union. That's grouping it with the next piece that is true, which is from 2 to infinity. And I'll put a parenthesis on that as well. Open paren and close paren for the infinity sign because we can never reach infinity. It's also important to point out here that you should never have a parenthesis if it's including the endpoint. And you should always list your values from smallest to largest. If you prefer this method of finding the interval that is true, you can go ahead and skip to D, but I'm also going to show you the table method. So we know that the same method applies all the way up to when we sketch the graph. Notice that I'd still factor it. I'd make a point of where negative 1 is and where 2 is. I'd keep these as open dots at negative 1 and 2, but then I would divide this up into 3 separate intervals. The interval from negative infinity to negative 1, the interval from negative 1 to 2, and the interval from 2 to infinity. And now I pick test points or test values. So I'll use negative 2 for the left interval, 0 for the middle interval, and 3 for the third interval, or the interval to the right. Doing a substitution into my polynomial, I will have -2 minus 2 times -2 plus 1. If I look at the signs on that, I will get a negative times a negative, which is a positive overall product. That corresponds to my first process. Then I will do a substitution for 0. 0 minus 2 is negative. 0 plus 1 is positive. And that will give me an overall negative product. If I substitute 3 in, I will have 3 minus 2 is positive. 3 plus 1 is positive. And that gives me an overall positive product. Now, the interval will again be exactly the same, and you can use either method. I don't mind. I just want to give you the option of either one. Let's take a look at this last polynomial. This one has a lot of roots in it. But first I'm going to identify the roots. The x cubed we would set equal to 0, and we would get x equals 0, and we would say multiplicity 3. We haven't talked about that yet, but it's there and it's not a huge deal at this point. We can factor the x squared minus 4. That will give me a binomial of x plus 2 and a binomial of x minus 2. I can set the 3x plus 5 equal to 0, and that will give me -5 thirds. I can set the 2x minus 9 equal to 0, and I will get a x equals, when I solve it, x equals 9 halves. I can also set these two binomials here equal to 0, and it will give me x equals -2 and x equals 2. So these are all the roots or points along my polynomial. Listing them from smallest to largest, I will have -2, -5 thirds, let's see, 0, 2, and 9 halves. Let's list or figure out the degree of this polynomial. I have an exponent of 3, an exponent of 2, that's 5, an exponent of 1, and an exponent of 1. So 3 plus 2 plus 1 plus 1, that's going to give me 7. So the degree is 7. It's odd. It's going to come in from the bottom left. At -2, it will cross over. At -5 thirds, it will cross over. At 0, it's going to flatten out and then cross over. At 2, it's going to cross over again. And at 9 halves, it will cross again. And it will leave from the top right. Notice that this polynomial has an odd behavior. On the left, it approaches -infinity, the polynomial does, and on the right, it approaches +infinity. This will be helpful as you move forward with these polynomials and learning how to graph things. But for now, let's just identify where this is positive and negative. To the left of -2 in the domain, the range is negative, so we'll say the range of this inequality is negative. Between -2 and -5 thirds, it is positive. Between -5 thirds and 0, the polynomial is negative. It is below the x-axis. Between 0 and 2, the polynomial is positive. The curve is above the x-axis. Between 2 and 9 halves, the curve is negative. It is below the x-axis. And between 9 halves and infinity, the curve is positive, above the x-axis. So now let's write the interval on which it exists. We have an inequality. Let's look at it again. We want to know where the polynomial is less than 0. This is negative, would be less than 0. So it's the interval from negative infinity to negative 2, negative 5/3 to 0, and 2 to 9 halves. Okay, so those highlighted regions are your intervals that this inequality is true. So I'll write it in interval notation from smallest to largest. We can never reach negative infinity, so we put our parenthesis negative infinity to negative 2. And since we don't have a less than or equal to, we're going to use parentheses for all these. This would be an open dot, open dot, open dot, open dot, and open dot for all these roots or zeros of the polynomial. We're going to put a union for the part that is positive, open paren negative 5/3 to 0, and then close the parenthesis. We have another positive interval, so we put a union, and then 2, so open parenthesis 2 to 9 halves, and then close the parenthesis. And we don't put a union here because this continues off to positive infinity for this part of the polynomial past 9 halves. And we're done.